This is the second lesson of transforming rational parent functions. Remember that the rational parent function is 1 over x. In the previous lesson, we looked at how we could add or subtract a number on the outside of the parent function, like plus 2, and that would move it up, it being the graph, or minus 2 would have moved it down 2. And we also looked at how you could write under the fraction or in the denominator a number like x plus 2, and that would have the effect of moving left, and a negative would have the effect of moving right. In this lesson, we're going to look at how you can reflect the entire graph across the x-axis, as well as how you can do a vertical stretch on the graph. So let's put the graph of the parent function y equals 1 over x on the screen here. This is a sketch I've made of it in blue. And the first thing I want to do is a transformation by saying y equals negative 1 over x. And the negative sign in front simply takes whatever the graph would have been and reflects it across the x-axis or across the horizontal asymptote if it has been moved. So in this case, we would redraw this graph by starting at the left side above the x-axis and going like this so that it moved upward toward positive infinity instead of downward toward negative infinity like it did before. And then once it reaches 0, which remember is undefined because we don't have division by 0, it will start again just to the right of the y-axis and move upward like this. Then go off to the right to positive infinity, all below the x-axis, which still acts as the horizontal asymptote, but in this case our graph is on the opposite side because it's been reflected across the x-axis. Okay, now I'm going to take this back off. And let's try this one. Y equals 2 over x. So now when we see y equals 2 over x, the effect is as if the 1 over x has been multiplied by 2. Anything larger than 1 that we multiply by is going to have the effect of stretching the graph. Now, one thing that we pointed out in a previous lesson is that the parent function basically has a key point here at 1, 1, and also at negative 1, negative 1. Kind of shows you where the curve changes direction here. Notice that if we have 2 over x, then when x is equal to 1, y is actually equal to 2, so that key point moves up to here. So the effect is, as our curve comes down, it makes a more shallow turn before heading off to positive infinity here. Same thing here with negative. When x is negative 1, then y would be negative 2. So again, we make a more shallow turn before heading off to negative infinity as we approach the y-axis. That effect is called a vertical stretch because it's as if you took the thing and pulled it upward like this and took the graph here and pulled it downward like this to get that effect. So these are stretches, and they're vertical stretches. So any number that we multiply the parent function by that's greater than 1 will have that effect of stretching. The larger the number, the more stretch you will see, and the shallower the curve will become as it changes direction to approach the x-axis on the right or to approach the y-axis on the left. In the next lesson, we'll look at what happens when we actually multiply by a number between 0 and 1, a fraction or a decimal.